Hi everyone. In today's lesson, we'll be taking a look at the transformed version of the tangent function. So in your notebook, please put down today's title, Transformed Tangent Function. The transformed tangent function has the following format. Y is equal to A multiplied by the tan of B times x minus h and then plus k. There are only a few elements that are required in order to draw a fairly decent tangent graph. The first of these elements is what we call the inflection point, which is given by the coordinate h and k. The inflection point is a point at which the s waves of the tangent function switch curviness. In other words, they switch from being concave to being convex, or vice versa. The next item we'd like to have in order to draw a decent graph is the period. In the tangent function, that is given by pi divided by the absolute value of the b. The next item we'd like to have are two consecutive asymptotes, and those are calculated by h subtract half of the period and h plus half of the period. One thing that should be noted is that the distance between two consecutive asymptotes also represents the period. And the last item we'd like to have in order to draw a decent tangent graph is its variation. This is given by the sine of a multiplied by b. If the AB combination is positive, then it's going to be an increasing S type of wave. And if the AB combination is negative, then it will be a decreasing kind of S wave. It's time to take a look at an actual example. Please put this down as our example. I'd like to draw the graph of negative 2 times the tangent of half times x minus pi over 3 and then plus 1. Since this is our first time, let's clearly mark down the variables that we'll be playing around with. First, let's indicate our inflection point, which is given by the combination of h and k. In this example, our inflection point will be located at pi over 3 and 1. Just a reminder that the inflection point is a point at which our S curves switch curviness. In other words, they go from being convex to concave or vice versa. Next, let's determine the period. In this example, the period is given by the calculation pi divided by the absolute value of b, which will give us 2 pi in this case. Next, let's determine two consecutive asymptotes. They are given by the calculation h subtract half the period and h plus half the period. In this example, that will give us two consecutive asymptotes located at negative 2 pi over 3 and positive 4 pi over 3. And finally, let's determine our variation, which is given by the sine of a multiplied by b. In our example, our AB combination is negative, therefore our S waves will be a decreasing type of S wave. Finally, with all this information in hand, we're ready to draw. In order to accommodate this example, you will need a Cartesian plane about this size calibrated in the following manner. For the x-axis, the easiest way to calibrate it is to start at the value of h and just keep jumping by the value of h. Go ahead, pause the video, and prepare your Cartesian plane now. With your Cartesian plane ready to go, let's get drawing. First things first, let's put down our two consecutive asymptotes. They are located at x equals negative 2 pi over 3 and at x equals 4 pi over 3. We're going to mark them down with two vertical red lines. Next, let's put down our inflection point for this cycle. In this example, it will be located at pi over 3 and 1. At this stage, we're actually ready to draw our cycle. If you want to be more accurate, you can plug in a few random x's to get you some coordinates in order to help you approximate this S-curve more accurately. I'm just going to do my best and draw that kind of curve. As long as you show that the curve switches curviness, or goes from convex to concave at the inflection point, the rest should fall into place. And finally, I would just like to mark down a reminder that the period is the distance between two consecutive asymptotes, and in this example, it was 2 pi. And that's all there is, ladies and gentlemen, to drawing the graph of a transformed tangent function.